I've been making a few USB devices, and logically the next step for me is MIDI over USB. Luckily this really isn't any harder than the human interface devices, only instead of the HID report descriptors, we send these custom descriptors that follow the audio control interface. Objective Development have an example of this, which itself is based on an example from a PDF file from usb.org. It's all pretty straightforward. The one thing to remember is that USB MIDI reports are 4 bytes, whereas MIDI messages are only 2 or 3 bytes. This extra byte contains a 4-bit cable number for piping multiple MIDI streams through the same port, and a code index number, which, as far as I can tell, is always identical to the status code of the MIDI message. I started by making this standard MIDI-enabled knob. Twist it and it sends MIDI. The lazy way of doing this is to just check if the current reading is different to the previous reading. But that's not actually sufficient because no matter how clean your power supply is, it will always be possible to position the knob on a boundary, and then it will flicker between values. The way to prevent this is to give it hysteresis. Sample at a higher resolution than you want, remember the position it was in when you last sent data, and only send new data if the absolute difference in readings is above a threshold. This is a pretty subtle difference, but this way you'll only get flickering if the power supply noise is bigger than the divisions. So here's our MIDI data coming through. We've got the full range, no flickering, and no loss of resolution either. Right, we're ready to start building USB MIDI controllers. I thought I'd make a USB breath controller just to see if the USB bandwidth will give it better fidelity, and I have a few other ideas, but while we're at it, I thought, since it's a bidirectional cable, I'd try sending data in the other direction. To do that, you do have to enable the write out function in VUSB's config header file, but once I'd realised that, I very quickly ended up with MIDI data arriving at the chip. This has become something of a nervous twitch for me. I can't help it. As soon as there's MIDI data appearing, I just think to myself, well, we might as well turn those note numbers into square waves. And before you know it, I've got the thing playing chiptunes. Of course, an opportunity then presents itself. This is my world's smallest MIDI synthesizer, and the biggest bit about this is the connector itself. So now I've built the USB version. I'd say it's about half the volume. Apart from the piezo buzzer, the entire circuit is contained underneath the black plastic inside the connector there. There is some utility to the old one. You can use it for testing if MIDI data is coming through on a cable, or if you happen to have a battery-powered keyboard with no onboard synth, such as a Yamaha KX5, it can be quite useful. But this can only be used if you have a laptop to plug it into. It is completely pointless. But of course I didn't build it for a reason. I just wanted the challenge of soldering it together. The biggest parts are the Zener diodes here, which I had to carefully grind down flat. What I probably should have done is written a bootloader that uses MIDI sysx. That would actually be really cool, because then you'd be able to update the firmware without needing to take it apart. You also wouldn't need to install anything on the host computer, since it's all class compliant. In fact, that would be a really useful program in general, even for things that aren't USB MIDI. You could have some way of triggering the bootloader, which would disconnect and then reconnect it as a MIDI device. I might do that.